Generating an AI picture is simple because any generic output suffices, but technical reports operate on strict, unforgiving parameters. In the built world, structural physics demand precise, deterministic answers. Out-of-the-box language models make probabilistic guesses. Deploying them for rigid workplace deliverables yields hallucinated filler. Trusting high-variance systems for critical infrastructure introduces a mathematical risk. This bell curve represents the central limit theorem applied to semantic probability. These models sample from the dense peak, choosing the most statistically average words. Your critical engineering insights exist solely in these extreme, low-probability tails. Standard prompts consistently fail to reach those isolated edges. You waste computing power generating uninteresting center mass data. This is a failure of probability math, not a lack of prompt engineering. During my PhD, I modeled extreme wind turbulence on massive concrete structures. Isolating edge cases within multidimensional probability densities is computationally difficult. Structural engineers use Latin hypercube sampling to divide that space into uniform tiles. We force the math to sample strictly from inside an individual tile. This constraint guarantees we capture structurally significant events. We gain efficiency by deliberately ignoring the high probability center. It outperforms random distribution checks in both speed and accuracy. Rigid mathematical constraints are the only way to extract precise answers. We can map that physical grid directly onto an LLM's semantic knowledge space. Retrieval-augmented generation is often mistaken for a complete technical solution. RAG acts as a variance reduction tool, squeezing the distribution, but it remains anchored to the center. It does not enforce determinism. To succeed, we must build functional boundaries inside abstract hyperspace. This requires breaking the semantic space into isolated executable processes. The ARCH framework applies these tiles to workplace AI deliverables. Tile 1, the strict ingestion of raw numeric results. Tile 2, the isolated construction of technical tables. Tile 3, the establishment of project history. Tile 4, locking the report skeleton. Tile 5, localized AI generation of the introduction. Subsequent tiles generate the methodology, results, and discussion in sequence. The final tile applies overarching grammatical and readability constraints. These sequential rules impose determinism onto the probabilistic engine. Every word is extracted specifically from the targeted probability tail. The resulting ARCH output adheres to your team's specific engineering standards. Your unique institutional processes define the boundaries of the framework. Competitors cannot replicate this output without possessing your specific deterministic blueprint. Identify your process tiles first, then constrain the model. Engineer your own framework to build a tool that no machine can replicate.